Welcome back to Simplified Chemistry. This is part 2 on how to calculate percentage yield. In this video, I'll show you how to calculate percentage yield based on mass. In part 1, I covered how to calculate percentage yield based on moles. Feel free to watch part 1 to make yourself familiar with both methods. When we are calculating percentage yield based on masses, we must make sure that our units are consistent. Both the actual yield and the theoretical yield must be presented in grams. In this example, 20.2 grams of butane 2O was reacted with excess sodium bromide and sulfuric acid to give 25.2 grams of 2-bromobutane. We asked to calculate the percentage yield of 2-bromobutane. First, we have to check that the equation is balanced. In this case, our equation is balanced. If the reaction was perfect, then 1 mole of butane 2O would react with excess sodium bromide and sulfuric acid to give 1 mole of 2-bromobutane. Remember, in the real world, most chemical reactions do not yield 100% because they do not go to completion, or they might have side reactions, or you might lose your product during the experiment. To calculate the percentage yield, we divide the actual amount of substance that we have obtained from the reaction with the maximum theoretical yield. The maximum theoretical yield is what you would expect to get if the reaction was perfect. Let's start by calculating the maximum theoretical yield of 2-bromobutane. In this reaction, 20.2 grams of butane 2O was used. Convert the 20.2 grams of butane 2O to number of moles. Number of moles of butane 2O that was used is equal to the mass divided by the molar mass, and this is equal to 20.2 divided by the molar mass of butane 2O, which is 74. This gives us 0.273 moles. From the balanced equation, we know that 1 mole of butane 2O reacts to give 1 mole of 2-bromobutane. We can use the balanced equation to work out the amount of 2-bromobutane that we would expect to get if the reaction went to completion. From the balanced chemical equation, we see that 1 mole of butane 2O gives 1 mole of 2-bromobutane. This means if we started with 0.273 moles of butane 2O and the reaction went to completion, then we would expect to get 0.273 moles of 2-bromobutane as the maximum yield. Since I'm using a method of mass, I need to convert 0.273 moles of 2-bromobutane to mass, and this is equivalent to the number of moles of 2-bromobutane multiplied by the molar mass of 2-bromobutane, and this is equivalent to 0.273 multiplied by 136.9, which gives us 37.37 grams. So if the chemical reaction was to go to completion, then we would expect to get a theoretical yield of 37.37 grams of 2-bromobutane. We can now calculate our percentage yield. We're given the actual yield in the question. 25.2 grams of 2-bromobutane was obtained. Substitute the yield and the maximum theoretical yield in the equation. This gives 25.2 grams divided by 37.37 grams multiplied by 100. This gives the percentage yield of 2-bromobutane as 67.4%.